ax squared. Find the value of a if f of x is continuous at x equals 3. If f of x is continuous at x equals 3, then that means that the limit from both sides are equal. So they're telling us that the limit as x approaches 1, that's 3. They're telling us that the limit as x approaches 3 of ax plus 2 must be equal to the limit as x approaches 3, because the limits on both sides are equal. Left hand limit is equal to right hand limit. And so the limit must also be equal to ax squared. So when you plug in the 3 now, you're going to get 3a plus 2. 3a plus 2 is equal to, plugging in 3 now, you're going to get 3 squared is 9. So you get 9a. I will bring over the 3a to get 2 is 6a. And since 2 is equal to 6a, you divide by 6 and so a must equal to 1 over 3. Alright, so that's the value of a. Alright, so hence a is equal to 1 over 3. A is equal to 1 over 3 for f to be continuous. For f to be continuous, a is equal to 1 over 3. Nice and easy. Part 2. Part 2 says, let g of x be x squared plus 2 over bx squared plus x plus 4. And it says, given that the limit as x approaches 1 of 2g of x is equal to the limit as x approaches 0 of g of x, find the value of b. Alright, so let's do that. So part 2. Alright, given that the limit as x approaches 1 of 2g of x, and that is equal to the limit as x approaches 0 of g of x, find the values of a and b. Now, looking at the function, looking at g of x is x squared plus 2 over bx squared plus x plus 4. So we're going to apply x as 1 first. When you apply x as 1, you're going to get 2 times in the, put in x as 1, you're going to get 2 times 1 squared plus 2 is 3. So 2 times 3 over 1 squared times b is b plus 1 plus 5. So that's 3 over b plus 5. And that's equal to, plugging in 0, you're going to get 2 over, plugging in 0, you get 0, you get a half here. When you plug in 0, you get a half on this side. So now we just need to transpose for b. So from this, the 2's cancel on both sides. I'm going to cancel this 2 here. I'm going to cancel this 2 here. Then I'm going to cross multiply. I'm going to cross multiply to get that. Cross multiplying, I get that 4 times 3 is 12. And so 12 is equal to b plus 5. And if 12 is equal to b plus 5, then b must be 7. So hence b is equal to 7. That's the value for b. B must equal 7. Nice and easy, soft. No issues right there. Now let's look at part 2. Part 2bi. So the limit as, alright, it's not limits anymore, this is differentiation. So part B says y is equal to 1 over root x. So it tells us that y is equal to 1 over the root x. And it says using differentiation from first principle, find dy by dx. So first thing you have to remember from first principle, that dy by dx using first principle is equal to 1 over h times the limit as h tends to 0 of, it's 1 over h times the limit as h tends to 0 of f of x plus h minus f of x. This is the formula to find dy by dx. It's f of x plus h minus f of x. Alright, and so what we're going to get then is dy by dx is equal to 1 over h times, you just need to plug in now f of x plus h. Plugging in x plus h in here, you're going to get 1 over the square root of 1 over the square root of x plus h minus f of x, and f of x is just 1 over root x. That's dy by dx, alright? Oh, I forgot to put in my limit. It's 1 over h times the limit as h tends to 0 of this. Oh gosh, I forgot my limit. 1 over h times the limit as h tends to 0 of this. Let's see how we're gonna simplify this now. To simplify this, first we have to join it as one fraction. Alright, so join it as one fraction to say dy by dx is now 1 over h times the limit as h tends to 0, limit as h tends to 0 of the limit as h tends to 0 of, multiply up this to get root x minus the root of x plus h and that's over root x times root x plus h. Alright? So this is what we have now. Now when you get to this stage now, you can tackle it in two ways now, but the shorter approach is going to be to multiply by the conjugate of the numerator. So now we're going to multiply by the conjugate of the numerator. So dy by dx is going to become 1 over h times the limit as h tends to 0 of. Let's plug in, let's work out that now. Let's write it out first. There's no need to skip any steps. So like write root x minus the root of x plus h over root x times root x plus h over root x times the root of x plus h and that is multiplied by the root of x plus the root of x plus h. So multiply by the conjugate. And anything you do to the numerator, you have to do it to the denominator. You have to multiply the denominator also by the root of x plus the root of x plus h. Anything you do to the numerator, you have to do to the denominator. All right, nice and easy, soft. Now that we're multiplying by the conjugate, in the numerator, it's going to become 1 over h times the limit as h tends to 0 of, now in the numerator becomes the difference of 2 squared. So it's going to simplify out to just be root x times root x is x. It's going to be a squared minus x plus h. So it is x minus x plus h over root x times the root of x plus h, root x minus the root of x plus h, times root x plus root x plus h. Now the thing is, we're always trying to cancel this h right here. To cancel this h right here, what you realize is that this part in the numerator is going to simplify out to just be x minus x cancel. So in the numerator works out to just be minus h. All right. Now we always want to cancel this h. This 1 over h, this h out here cancels this h. So you end up just left back with minus 1 over this. Now when you cancel out this h, now you can apply h being 0. And so it works out to be minus 1 over, plugging in 0 now, root x times root x is just root x times root x is x. So you get minus 1 over x times, plug in h as 0 here, root x plus root x is 2 root x. This is 2 root x. All right, nice. So this works out to be minus 1 over 2x root x. Nice and easy. So that's dy by dx. This is the answer. 2x root x. That's dy by dx. All right. Now, if you don't believe your answer, you can always check it. That's the beauty about first principle. You can know when you're right. You don't need an examiner or your lecturer or your teacher or wherever you do math. You don't need anybody to tell you if you're right, because you can differentiate it to say if y is equal to 1 over root x, in reality, y is x to the minus half. If I am differentiating x to the minus half, then I would get that dy by dx. In reality, dy by dx would be carry down the power, which is minus a half, subtract 1 from the power, which is x to the minus 3 over 2. And so what you'd realize is that dy by dx, x to the minus 3 over 2, is actually minus 1 over 2 times x cubed all square rooted. That's dy by dx, but this can be simplified to be minus 1 over the square root of x cubed. You can write that as 2 times the square root of x squared times the square root of x. And then the square root of x squared is just x. And so you still get that dy by dx is minus 1 over 2x root x. So this is just confirmation that our answer is correct. This is confirmation. This is just confirmation. Confirmation. Just confirmation. All right, nice and easy. Now the second part of the question says, it says if y is equal to x over the square root of 1 plus x, determine an expression for dy by dx. So it says y is equal to x over the square root of 1 plus x. Y is equal to x over the square root of 1 plus x. So if y is equal to x over the square root of 1 plus x, find dy by dx. I'm going to use implicit differentiation. All right, I can't bother to work with, oh, well, let's not do that then. I just couldn't bother work with the square root. Let's just differentiate it normally. So dy by dx is equal to, you start with the bottom, which is 1 plus x square rooted times the differential of the top. The differential of x is 1, so minus the top being x times the differential of the bottom. The differential of the bottom is carry down the power half, then you subtract 1 from the power, which is 1 plus x to the minus half subtract 1 from the power, yeah, divided by the square of the denominator, which is 1 plus x. Better to use implicit. I wouldn't have to be working with no negative powers. So yep, square root of 1 plus x, carry down the half, subtract 1 from half is minus half, times the derivative inside the bracket of 1. So this is fine. So simplifying this, we're going to get that this is equal to the square root of 1 plus x minus, now this part can be written as minus x over 2 times the square root of 1 plus x. All I'm doing is simplifying this, and all of this is divided by 1 plus x. The question said to simplify your answer fully so you're not finished. You can then write that this is going to be multiply up 2 times the root of 1 plus x, and you're going to get 2 times the root of 1 plus x times the root of 1 plus x is just 1 plus x. So you get 2 times 1 plus x. You get 2 times 1 plus x minus x over 2 times the root of 1 plus x divided by 1 plus x. Which is equal to this divided by this. Now 2 plus 2x minus x, that's going to be 2 plus 2x minus x. That is this divided by this. It's simplified. 2 plus 2x minus x is just 2 plus x. So all of this just works out to be 2 plus x divided by this. So it's going to work out to be 2 plus x divided by 2 times the square root of 1 plus x times 1 plus x. Nice and easy. That's the answer. 2 times the square root of 1 plus x times 1 plus x in the denominator. Alright, that's the answer. Now, would implicit have been easier? Or, this is for persons that would have wanted to do it implicitly. You could have done it implicitly by going squaring both sides. You'd have gotten y squared is equal to, that would have been x squared over x squared over, when you square this, the square would cancel. So you just get 1 plus x. Alright. And then I'm going to rewrite this as x squared times 1 plus x to the negative 1. I'm going to use implicit. Using implicit, differentiating both sides now with respect to x, you get 2y times dy by dx, 2y dy by dx. That would be equal to, keep the first, that means times, keep the first, times the derivative of the second. The derivative of the second would be carry down the power minus 1, subtract 1 from the power to get 1 plus x to the minus 2, plus keep the second times the derivative of the first, plus keep the second times the derivative of the first, which is 2x. This is telling me that 2y dy by dx, if I had to continue around here, I'm getting 2y dy by dx. This is if you wanted to do it implicitly. 2y dy by dx would work out to be equal to, this part is going to simplify to be minus x squared over 1 plus x all squared. This would be minus x squared over 1 plus x all squared then I have plus 2x over 1 plus x plus 2x over 1 plus x. And so I could then divide through by 2y. Dividing through by 2y, that would then tell me that dy by dx is equal to, dividing through by 2y, I would get that it is equal to minus x squared over 1 plus x all squared times y plus 2x over 1 plus x times y. And then you could resubstitute what y is. Remember what was y? Y was x over the square root of 1 plus x. So you could resubstitute then and get that. It's a good thing we didn't do it implicitly. It's actually a longer method. So we get that dy by dx would be minus x squared over, this would be 1 plus x squared, 1 plus x all squared times the square root times y now, and remember y in this case is x over the square root of 1 plus x plus 2x times 1 plus x times y, and y would be x times the square root of 1 plus x. This is way longer, implicit, so don't do implicit then. 1 plus x. And then to simplify this now, and you'd want to say, oh gosh, I have to simplify this. Yes, to simplify this now, you would have to go that this would become minus x squared over 1 plus x squared times x. Remember, 1 plus x squared is 1 plus 2x plus x squared. And then you multiply that by x. So it would be 1 plus x squared times x, 1 plus x squared, 1 plus x all squared. And this would be times x. And it would be all of this is divided by the square root of 1 plus x. Now, when you have this now, let me just do it in one step. Think of it as a divided by b over c. It works out to be a times c. So I'm just going to do it in one step. All of this, I'm just going to do it in one step. A divided by b over c is a times c. So it works out to be minus x squared times the square root of 1 plus x over x times 1 plus x squared. And then as you realize, for this side, the x cancels the square. And then this part will give you plus, it's going to be 2x times the square root of 1 plus x over, this is x times 1 plus x and this x cancels this x, and so the final answer that you get is pretty much the same as the other one. The final answer is the exact same thing. We just need to simplify it some more. So in this case, it gives us that dy by dx is minus, we could make the LCM 1, and so it is minus x. If you want to make the LCM 1, it's really minus x times 1 plus x times the square root of 1 plus x plus 2 times the square root of 1 plus x over 1 plus x. All square. So this is dy by dx. All right, this is an alternate way to do it. You could actually factor out 1 plus x. The square root of 1 plus x, you could factor that out and simplify in the bracket. You're going to eventually get back the same thing. All right? So either way you do it is fine. Either way. Now part C. Part C tells us that dy by dx, it says x is equal to cos theta. So let's do that. X is equal to cosine theta. X is equal to cosine of theta. And it tells us that y is equal to the sine of theta. X is equal to cos theta and y is equal to the sine of theta. And so first thing we need to find is dx d theta. So dx d theta, when you differentiate costs, let me write that better. That's not gonna look too pretty. So when you differentiate with respect to theta, so dx d theta is going to be equal to, when you differentiate cos, you get minus sine theta. Alright, when you differentiate cos, you get minus sine. And then when you differentiate, you find dy by dx, or dy by d theta. When you differentiate sine, you get cos. Alright, nice and easy. So what does that mean? That means that dy by dx, is going to be equal to dy by d theta, times d theta, times d theta dx. And so it's going to work out to be dy by d theta is cos theta times d theta dx, which is really divided by the minus sine theta. But then cos over minus sine is minus cot. And so dy dx is minus cot theta. All right, nice and easy. That's what we have, minus cot theta. All right, nice and easy. And this takes care of question 5, solved. All right, finally, question number 6. Question number 6 says the gradient of a curve passes through the point -1, -4, and is given by, you tell us that dy by dx is equal to 3x squared minus 4x plus 1. And it says, find the equation of the curve. To find dy by dx, right, since you already have dy by dx, then the equation of the curve y is going to be equal to the integral of dy by dx. So y is equal to the integral of 3x squared minus 4x plus 1. That's dy by dx. 3x squared minus 4x plus 1 dx. That is y. So now you integrate that, and what you're going to get is 3x cubed. You get 3x cubed over 3 minus, add 1 to the power, you get 4x squared over 2 plus 1, that's just x, alright, plus some constant c, alright, and that's the equation of the curve. If you want to go ahead and simplify it, you're going to see that y is actually just x cubed minus 2x squared minus 2x squared plus x plus c. Nice and easy. Now you need the point -1, -4. So at -1, -4, at -1, -4, y is -4. So it's going to be -4 is equal to -1 cubed, which is -1, minus 2 times -1 squared plus -1 plus c. That will allow us to find the constant c. All right, so solving for c, we're going to see that -4 is equal to, put it in the -1, we get -1 minus 2 times -1 squared plus -1 that is negative 4. So minus 4 is equal to negative 4 plus c, and so the constant is 0. So if the constant is 0, the curve passes through the origin. And so hence the curve is going to be, this is part I, the curve is just going to be y is equal to x cubed minus 2x squared plus x. Nice and easy. So now the second part of the question says, find the coordinates of the stationary points and determine their nature. So to find the coordinates of the stationary points, well, that's no issue. So we go ahead now and to find the coordinates of the stationary points, we go ahead and solve dy by dx equals 0. So we solve dy by dx equal to 0. We solve dy by dx equal to 0. By solving dy by dx equal to 0, we are solving 3x squared minus 4x plus 1 equal to 0. And by solving this equal to 0, we factorize it. By factorizing it, what we're going to get is signs are the same, and both of them is negative. So this is minus, this has to be x, and 3x. And so the stationary points are going to occur when x is equal to 1, or when x is equal to 1 over 3, 1 upon 3. So now that these are the two stationary points, what do we do? Now x is 1, we need to find y. When x is 1, we plug in 1 here, we have 1 cubed minus 2 times 1 squared plus 1. So when x is 1, we get y is 0. Then we'll put in 1 over 3. We're going to have 1 over 3 cubed minus 2 times 1 over 3 squared plus 1 over 3. And that's 4 over 27. So this is giving us y is 4 over 27. So those are the two stationary points. So let me just put it as a point. You have 1, 0. Then you have 4 over 1 over 3, 4 over 27. That's another stationary point. 4 over 27. Now you need to find out what is dy by dx. Now it says determine their nature. So since we need to determine their nature, we need to find the second derivative to do that. So the second derivative d2y by dx squared, that's going to be equal to, you differentiate dy by dx to get 6x minus 4. All right, 6x minus 4. Now at the point 1, 0, the second derivative, don't, just for space, second derivative is often written as y prime prime, meaning you differentiate y twice. At 1, 0, y prime prime is equal to, you plug in 1, you get 6 times 1 is 6 minus 4 is 2, which is greater than 0. And so therefore 1, 0 is a minimum point. So 1, 0 is a minimum point. And then now you need to find y prime prime over here at 1, 3. At the point 1, 3, you have y prime prime is going to be equal to, when you plug in 1 over 3, you get 6 times 1 over 3, 2 minus 4 is negative 2, which is less than 0. And so 134/27 is a maximum point. So this right here is a maximum point. That's a maximum point. Nice and easy. So we have the minimum point and we have the maximum point. Now that we have the minimum point and the maximum point, it says hence sketch the graph. So to sketch the graph now, we create our, I like to sketch it first. So I just like to do what's called a freehand sketch. That's my freehand sketch. All right. This is the maximum turning point, the minimum turning point, and I label them. This is the point 1, 0. And this is the point 1/3, 1/3, and I think it was 4/27. I like to do a freehand sketch first and then label the axis. All right, so now I can label axis. Now x-axis is right here. When y is 0, that's the x-axis. Yeah, that should be fine. Now the y-axis now occurs when x is 0. So if this is 1/3, we can put the y-axis somewhere here. That's the y-axis. And how do I know it is right there? Because the question had told us how to make the line straight. Yeah, so that's the y-axis. So making sure you label all intercepts. So let's label them. In labeling all the intercepts now, we had our maximum stationary point. We labeled that already, 1/3, 4/27, minimum stationary point, 1/0. And this is also a root, and the next root is when x is 0. So next root when x is 0. All right, so that's the point 0, 0, which is the origin. All right, so if you want to tell them and just write down, just to tell them that your roots are, just tell them the roots are 0 and 1. Tell them that your y-axis intercept is the point 0, 0. And then you already have your minimum stationary point, minimum stationary point. The minimum stationary point is 1, 0. You can tell them your maximum stationary point from your graph, maximum stationary point. That is the point 1/3, 4/27. There we go. Nice. Let's go to part B now. Part B says we are supposed to evaluate the integral from 0 to 3. Evaluate the integral from 0 to 3 of 2x plus f of x is 2x times the square root of 1 plus x. Evaluate the integral from 0 to 3 of 2x times the square root of 1 plus x dx. Now to do this integral, right, to do this integral, You can use substitution, so you can call u is equal to 1 plus x. Oh, this is 1 plus x squared. So u is equal to 1 plus x squared. If u is equal to 1 plus x squared, then du is going to be equal to 2x dx. This is 2x dx. And so then that means that the upper limit, you're going to change the upper limit. The upper limit is going to be equal to, when x is 0, the upper, when x is 3 rather, 3 squared is 9 plus 1 is 10. So the upper limit becomes 10. And the lower limit is going to become, put in x as 0, and then 0 plus 1 is 1. And so now we can rewrite this as the integral now from a new lower limit of 1 to an upper limit of 10 of, this is now 2x dx is du, and 1 plus x squared is u. So this is now the square root of u. So it's 1 to 10 of the square root of u du. Doing this integral, this is u to the half. So we add 1 to the power to get u to the 3 over 2, divide by the power of 3 over 2, and we're integrating that from 1 to 10. Nice and easy, soft. So you work that out now. You plug in 10. First and foremost, 1 over 3 over 2 is 2 over 3. So I'm going to factor out the 2 over 3. Write it as 2 over 3 times. This part can be written as u cubed square rooted from 1 to 10. I'm just making it a little prettier. Now you can find the integral of that. That's going to be equal to 2 over 3 times, when you plug in 100 cube, so you plug in the cube root of 1. Where does 100 come from? That should be 10. 10 cube square rooted minus 1 cube square rooted, and you work that out. So that's going to be 2 over 3 times 100 cube is 1000, and the cube root of 1000, the cube root of 1000, right there, 10 cube, and then we square root 10 cube, then we subtract 1, then we multiply it by 2 over 3. I was trying to write this as a pretty answer, but it's not coming to me, so I'll just leave it exact. It's 2 over 3 times the square root of 1000 minus 1. I wanted to write it prettier, but it's not coming to me right now. Maybe we can break this down using surds. Right, we can break that down as maybe 4 times 250. Yeah, we could break this down using surds. We could. We could actually break this down using surd. Maybe you could break it down as 2 over 3 times. I just like when it looks prettier. 1000 is really 25 times 40. And so that's 5 times the root of 40. And the square root of 40 can be broken down as 4 times 10. And the square root of that, just trying to write it prettier. Let me see. That's 2. 2 times 5 is 10. Yep. So I can write it as 10. 10 root 10. Yeah, this looks better. 10 root 10. 10 root 10. 10 root 10. Yeah, this looks better. 2 over 3, 10 root 10 minus 1. It looks better to me. It's not annoying anymore. So that's that. Nice. Okay, let's continue. It says find the volume generated by rotating the area bounded by the curve above in the x-axis and the line x equals 0 and the line x equals 2. So remember, volume around x-axis is equal to pi times the integral of y squared dx. It's pi times the integral. So volume is going to be pi times the integral from 0 to 3 of 2x times the square root of 1 plus x squared. 2x times the square root of 1 plus x squared. It's already square dx. That's going to be the volume. So that's going to work out to be pi times the integral from 0 to 3 of 2x squared. It's going to be 4x squared. It's going to be 4x squared multiplied by 1 plus x squared. That's when you expand the perfect square. This is what you'll get. Let me fix this one. Supposed to be 1 plus x squared. Close the bracket there. And then I work this out. And I work this out. And I get pi times the integral from 0 to 3 of 4x squared times 1. That's 4x squared. Plus 4x squared times x squared is 4x to the 4th power dx. Alright, and then now I'm able to include by adding 1 to the power to get 4x cubed over 3 divided by 3 plus add 1 to the power to the 4x to the 5th divided by 5, and I'm integrating from 0 to 3. That's going to be equal to, and remember all of this is multiplied by pi. So it's going to be equal to pi times, let's plug in the 3, we don't need to plug in 0. Just check in to make sure we squared it properly. 2x squared, 2 squared is 4, x squared is x squared, the root of 1 plus x. When you square that part, it's going to be root, the square cancel the square root to get 1 plus x. When we expand this, then we get 4x squared plus 4x to the 4, so we're fine. Add 1 to the power, divide by the power, so we're good. So plug in 3 now. We're going to have 4 times 3 cubed divided by 3, that's 36, plus 4 times 3 to the 5th power divided by 5, 4 times 3 to the 5th divided by 5, that's 194.4. And so you add those together and you get the volume. So when you finish, the volume is going to be 194.4 plus 36, which is 230.4 pi. 230.4 pi. And remember, volume is in units cubed. Nice. Now, The only issue is that you have this, some persons like to express it in fraction. So some people might probably want to write it as 1152. Maybe you want to write it as 1152 over 5 pi. If you write it like that, that's totally fine. If you want to write it like that, 1152 pi units cubed, that's no problem. So this takes care of this paper, and it was nice and easy. No sugar, it was just plain and simple, and I just wish you all the best practicing for your exam.